So, starting this year and lot of this is from Proof and Oxford. So in fact, this is taken directly from there. This is you have the figure numbers, exact figure as it is. I stick to the notation from there. So what this says is. Interest rate parity. This says that the interest rate in two countries, or more generally the return rate on two assets in two different countries in two different currencies. That is more important. Actually, it is not particularly important to talk about two countries. All you need to do is to talk about two currencies. Why I'm saying this is because if you are in a financial center like London, you can have debt instruments in euros and dollars, in pounds. You don't have to be a resident in the US to talk about US dollar vis-a-vis the pound or US dollar vis-a-vis the euro. So it is different currencies and it would be available within the same country. So here really what we are talking about is the numerator in terms of which you are denominating okay, so what this says is that let's begin with from the beginning, simple. If the exchange rate is completely fixed between two currencies, as it used to be under both standards, then the price of each currency was fixed in terms of gold. Since the price of dollar is fixed in terms of gold, the price of pound is fixed in terms of gold. Therefore, it follows that the price of dollar is fixed in terms of pound. So you have fixed exchange rates in effect. Occasionally there would be these cases, but ignore them for simplicity. Then in that case, it is effectively actually one currency. You're using different names, but as far as the values go, it is one and the same thing. It's just that you have different names and different units. So one is a bigger unit, another is a smaller unit, but for all practices, it's the same currency. And then it is not surprising that one should expect in a situation of free trade, free capital mobility, you would have the interest rates on debt instruments denominated in different currencies. The interest rate should be equal. So the interest rate on pound instrument should be the same as the interest rate on the dollar instrument in a hypothetical stylized world. But the moment you go on to flexible exchange rates, and this is what we are talking about. This is the more interesting case. In that case, you have, so in this case, you have actually interest rate equality between the two. It's the same interest rate on two instruments. But here you have to worry about the exchange rate. So we take an example. If suppose the interest rate on the Indian rupee instruments is 10%, and the interest rate on dollar instruments is 2%. So you have a gap of 8% between the two. What explains that 8%? Well, the market expects the rupee to depreciate by 8% per annum on an average. This is the expectation. It could be that it depreciates more. It could be that it depreciates less. It could be that it even appreciates, but that's a different matter. The expectation is that there should be a depreciation of the rupee by 8%, and therefore the 2% interest earned on a dollar instrument is equivalent to a 10% interest rate earned on a rupee instrument. that is the interest rate parity. And you may be familiar with this. I'm just using this as a way of background for this, which is the issue of determination of exchange rate. So what Krugman and Oxford are arguing is that when you consider three things, price levels, interest rates and exchange rates, then the price levels tend to be the most sluggish or rigid, as you may have come across in much of your macroeconomics. Interest rates are more variable, but relative to that, exchange rates are the most fluctuating one. So here, what they are arguing is that given the return rate in dollar terms, so this is the interest rate in dollars. I gave earlier an example of rupee and dollar. I stick to this diagram, so this is dollar and euro. That's the way it's considered improvement. So this is the interest rate on dollar debt instrument. And again, for simplicity, there is one kind of debt instrument, because when you talk about interest rates, there's a whole variety of interest rates that you can have. So make it simple, one interest rate in terms of dollars and another interest rate in terms of euros. And this is given exogenously, the interest rate on a dollar instrument. And what you have is another curve. So there are two curves. These are not demand and supply curves. Let's be careful about that. This is simply the exogenous given interest rate on dollars and the return rate on the euro instrument at each current exchange rate. So there are two exchange rates. One is the current prevailing exchange rate in the market, and we are determining the current prevailing exchange rate, dollar in terms of euros. And this is the price of euro. How many dollars do you need to get 1 euro? So suppose, for example, let us say this is 1.25, this is 1.5, so $1.5 per euro, and let us say this is $1 per euro. So at this price of euro, you have the return rate on the euro instrument exactly equal to the return rate on the dollar instrument. If the price of euro is higher, then the return rate on the euro instrument is less than the return rate on the dollar by this much gap. And in case the euro price is low, then you have the return rate on euro instrument being more than the return rate on dollar. Now, since you have active arbitrage operating in the market, and here we are talking about the exchange rate market, the exchange rate which will equalize the return rate on euro instrument and return rate on the dollar instrument is this. At this exchange rate, you have an equality between the two return rates. So you will not have an exchange rate of 1.5, you will not have an exchange rate of 1, you will have an exchange rate of 1, at which the two return rates are equal. So the bottom line here is that the current exchange rate is determined given the interest rates on the two debt instruments, and given, I should have mentioned that explicitly earlier, given the expected long-run exchange rate that we have. So there are two exchange rates. One is the idea of an expected exchange rate, and the other is the current prevailing exchange rate. So we are taking the expected exchange rate to be given, which is the consider that the norm or the expectation. Take it for, if you like, one period ahead, and this gives you the how the current exchange rate is determined given the return rates on the debt instruments. Any question on this? So, the next one, this is, in the previous figure, we took the interest rate of each country to be given. I will use the terms interest rate in each country and interest rate on each currency as interchangeable. But as I said, the more important thing is interest rate associated with a currency rather than with a country. So here is the definition of the interest rate, which was taken exogenous in the previous figure. So how is the interest rate determined? Again, this is looking at the short run. I'm beginning with the short run and then move on to the long run a little later. So this is again something that you would have come across in some form or the other earlier, but it's important to put the pieces together. So let us say that this is the money supply, and let us say this is the real money supply. Well, it is reasonable to take the money supply to be exogenously given. But what about the price level? As I said, we are considering the short run, and the short run, and I will show you some data also a little later, where you see that the price levels do not change so quickly in the short run. So you can take that as exogenously given. So it is not only the nominal money supply which is exogenously given, it is also the price level which is exogenously given. So the real money supply is exogenously given. Incidentally, also here you can simplify by taking the money supply to be the money issued by the central bank. Now, as we know, in practice, we have money equal to, as a simple definition, two kinds of money: the money issued by the central bank, which is currency, and money issued by the commercial bank, which is deposits. So this would be the, if you like, broader definition of money. But for this analysis, you can keep it simple and take it as if money is equal to currency. This is just for simplified purposes to make the assumption of exogenality of money supply more meaningful. So the other bit can also be handled, not a problem with that. So that is the exogenously given money supply, which is why it's straight line there. And the other term is the demand for money, demand for real money, that is aggregate real money demand. That as a function of the interest rate on the y-axis. So the higher the interest rate, the lower the amount of money is, because there's an opportunity cost of holding money, and if you take the return on money to be zero, then you are incurring an opportunity cost when you are holding money. So you would like to economize when the interest rate is high, and when the interest rate is low, then the demand for money goes up. Here we are taking the income to be exogenously given. As I said, we are considering the short run, and the emphasis here at the moment is on monetary and financial factors. So national income is being taken as exogenous. So the demand for money and the supply of money. The demand for money, of course, at the level of the economy as a whole. This is the aggregate demand that we are talking about. So, if the interest rate is high, then the supply is greater than the demand. If the interest rate is low, the demand is more than the supply. So, the market clearing interest rate here would be where the demand for money is equal to the supply of money, which is this interest rate. I'm sure this is familiar in some form or another. Please feel free to ask the question. prefer it. Okay, so this is now putting the previous two diagrams together. The diagram up there is what I showed you initially, and this is the diagram that I showed you next. This is now the third diagram. It's just that the scale, the axis quadrant has been inverted. So it was shown like that. It has now been turned down. So you have real money on the y-axis on this side, and there the axis is different. But it's not that you have one y-axis with one thing, positive values there and negative values there. That's not how the diagram is to be created. These are positive quantities of real money as you go from here, and these are the positive the exchange rates on the y-axis as you go from 0 up there. So in the first diagram, the interest rate on dollars was taken as exogenously given, but you can see where it's coming from. In the short run, it is determined by the monetary factors. So if the central bank were to increase the money supply, then the interest rate would go down. You can consider other comparative statistics also. So here we move one step further. In a sense, what you're doing is determining the interest rate and the exchange rate together in this. So simultaneous equilibrium in the US money market and the foreign exchange market. Both asset markets are in equilibrium at that interest rate and at that exchange rate. This is a nice chart to see what is going on. So you have here two regions, United States and Europe, and you have here the European system of central banks. As we know, there is the European Central Bank, and then there are the central banks of each country within the Eurozone. That's a bit similar actually to the Federal Reserve System, which is also where you have several regional Fed banks. And you have the European money market and the US money market. The US Fed decides on the money supply, though a good part of it is also endogenous, but for simplicity here, treat that as exogenous. Similarly here, the European money market, the money supply coming from the central banks, and then where do the two money markets interact, the US money market and the European money market? That's the foreign exchange market, and you get the exchange rate here. As in the previous case we saw, the simultaneous determination of the interest rate and the exchange rate in the short run. Given income, given price level, and so on. Here is a chart to show the relationship between money growth rate and inflation. So this is quantitative theory of money. This is again something that would be familiar, which is to say that in the long run context and in the context of an average taken over a large sample of countries over a large number of periods, you have a relationship between the percentage increase in money supply and the percentage increase in the price level. So this is what shows Milton Friedman's famous statement that inflation is always and everywhere a monetary phenomenon. You can see that here as the money supply goes up, the growth rate of prices, which is the inflation rate, goes up. Of course, this has been a debatable issue, and here what you see is a correlation. There is more complexity to that, and the economics profession is not unanimous in this view. There are things like cost push inflation, food inflation, oil inflation. To give an example from recent times, in India, the last few years, the inflation rate has been high, and it was associated with the food prices having gone up and on earlier occasion on the fuel prices having gone up. It was not related to the money supply rate having increased. So there are difficulties with this. But as a broad style extract, it does bring in the money and price relationship into it.
Also, if you just, I mean, this is such a big aggregative graph. Yeah. All the countries put together and bunching, I mean, I can understand that money and inflation have very close link when you have very high inflation. But I mean, there are growth implications when you have money supply growth too low, which is the present phenomena going on world recession. It's basically the money supply. So that is something kind of a non-neutral kind of a relationship. If you have too much money supply, inflation goes up, which I think everybody agrees. But if you have too low money growth, then your economy is in recession. That somehow, I mean, Krugman does highlight, or even others highlight, but somehow that gets missed in the entire debate.
Yeah. So that's the added dimension. One is whether or not the relationship holds linearity. It does not. The other bit is that this is showing only M and P, and as has been pointed out, there's also an issue of the real sector of the economy, the income and the employment, and it could be that one is sacrificing output and employment in controlling inflation, particularly to monetary policy, which is what is happening at the moment to some extent. So there is another element too. But yes, there is, you have to keep in mind the output, which is not being considered here, and that's particularly important in the context of low rates of growth of money and low inflation rates. In this context, 10% inflation is high in India, and but in the context of Latin American countries where it could have where it has gone up much further, our story is much better.
Also, I think if you look at the Great Depression work of even Friedman, he also admits that one of the causes for Great Depression was too low money supply. I mean, he has openly admitted that part in his classic work. And that also, I mean, obviously not getting highlighted enough. Everybody thinks money supply is the main reason for inflation. And that's why everybody wants to control money inflation. And the recent Japanese initiative by the new Prime Minister is basically saying that I will have a huge Keynesian fiscal stimulus. And I'll ensure the Bank of Japan accommodates that. So that the inflation, which is completely sometimes seen as a very negative thing, may not be very completely negative thing, especially when you are experiencing deflation.
Yeah, so in other words, inflation we usually associate with costs, that there are these costs of inflation, the negative side of inflation. What is being pointed out is also the positive side of inflation, that you can have benefits of inflation as you can have costs of inflation. So which is why the policymakers are in a dilemma on how far to go in controlling inflation. If it was not for the benefit side, then of course the answer would be simple, keep inflation to zero. So this is to show the fluctuation of price levels and fluctuation of exchange rate. it's not price level, it's ratio of price levels, which is what is important in the context of purchasing power parity. Familiar to already, but I'll come to it a little more. So what you can see is that there are these two curves here, the thicker one and the one which is got shorter amplitude, much less fluctuation, and you have the exchange rates which have considerable volatility. As I said, the price levels tend to be sluggish in the short run. Exchange rates are a lot more volatile, and you can see this in this picture, which is why in that first diagram, not in the first, the second one, we were considering the price level as given. So this was the reason behind that assumption in the context of determining exchange rates. This is US-Japan price level ratio. This may need a bit of explanation. You know overshooting of exchange? No. No. Okay. So this is what is called overshooting. So what is being considered here is a permanent increase in US money supply. So let's make the analysis simple. Consider a situation where to begin with you had a given money supply, fixed, exogenously given, and you had an equilibrium with that. You had some price level, some interest rate, some exchange rate, and so on, some income level. And then we are considering comparative statics. Comparative statics, you move from one equilibrium to another due to shift of some exogenous factor. So the exogenous factor being considered here is US money supply, and it is the amount that we are considering. We are not considering the growth rate. I'll come to that. I think it's the next diagram. So if the amount of money supply goes up, then what happens? That first diagram is the most straightforward one. From 0 to T naught, during that interval, the money supply is constant at M1 US. This is for the US economy. And at point T naught, you have a jump in the amount of money. Exogenous change in the amount of money in the economy, and that goes up from M1 to M2 in the US economy. So the first diagram is it's straightforward. Now, if you use the quantity theory of money, then another part also follows neatly, which is that the price level would go up, taking the maximum to be given. So let us assume that the money supply doesn't affect the income. It can in the short run, but for this purpose, let us abstract from that bit and look at the monetary effect, the exchange rate, and the price level bit. So the price level would go up from P1 to P2. Since the money supply goes up, the price level goes up. And as we saw in the earlier diagram, if we are considering the simple world in which you have quantity theory of money relationship, increase in money leads to increase in price level. But there is this other element which we are not abstracting from, which is that the price level tends to be sluggish in the short run. If that is so, then you will not have a jump from here to here at this point, just as we have in the case of money. There it is a jump from M1 to M2. Here you don't have a jump from P1 to P2. Instead, you have a gradual increase in the price level. It moves and it slowly approaches P2. Now, that creates a bit of complication. And the other part, before I come to the complication part, consider the other part, which is the dollar interest rate up there. So you have an increase in money. An increase in money, this is the quantity theory of money effect. The price level goes up. That is the Keynesian liquidity effect. what does that say? It says that when you increase the amount of money in the economy, then the liquidity goes up, and that pushes the interest rate down. So the interest rate falls due to more money in the economy. So that is what is being shown there, and this effect is fast. So unlike the price level, which is sluggish and changed slowly, there the interest rate moved down from R1 to R2 at the time that the money supply increased. So that part is also neat. But the other bit is that remember that this is short run effect. The liquidity effect is short run. You increase the amount of money in the economy and the interest rate goes down. But in the long run context, the interest rate is determined not by monetary factors, but by savings and investment, which are the parts from the real sector of the economy. So the greater the demand for investment, the higher the interest rate, the more the savings, the lower the interest rate. So it's the savings and investment which determine the interest rate in the real sector. So in that sense, the interest rate is not a monetary variable. It is a real variable related to how much of consumption I am willing to forego and what is the demand for the goods and services foregone. What's the demand by firms in the economy. So since the amount of money in the economy doesn't change the real things in the economy, naturally, if you use the printing press, that's not going to change the technology in the economy or the savings behavior of the economy or any of the real things in the economy. So it is not surprising that the interest rate should come back to its previous level. So that is what that part of the diagram shows. That over time, gradually the interest rate comes back to the original level. This is an old idea due to Mitchell, many others, just to argue that the central bank can affect interest rates in the short run, but not in the long run. So in the long run, this interest rate is moving back to where it was previously, but it can take some time. Are these three parts clear before I come to the fourth one? Somebody asked me one question before I speak. It cannot be that you don't have any question on the top.
Everything absolutely clear.
I can't be that good.
No, they are very good.
No?
Shouldn't the diagram be negative slope rather than positive sloping?
This one?
The dollar interest rate and time?
No, it's down from R1 to R2, that's the liquidity effect.
But it's going down. R2 is down than the R1.
Yeah, so money supply has been increased. So money has been increased from M1 to M2.
So why don't we start from,
Say, the farmer and come here and then go back. Why don't we start from there and come back? No, we are not moving back in time. What we are saying is that from 0, so this origin to T0, the interest rate stays fixed at R1. But R1 is what is graph? This on the x-axis is time, on the y-axis is the dollar.
No, that's the curve.
So that curve shows how the interest rate moves from R2 to R1 over time.
So to start with, it is at R1.
To start with, meaning at the origin,
When we multiply before T0.
Before T0, the interest rate is at R1.
That's reflected in what condition here or?
No, so there is a dash part, so so the non-dash part, so that is the prevailing interest rate from 0 to T0.
So there is a break in the.
There's a break. There's a break. I am calling it a jump. So there's a jump in the interest rate. The interest rate falls. Just as there is a jump here for money. The money supply goes up at point of time T0, the interest rate moves down at point T0, and that is the liquidity effect. And since the interest rate has to come back eventually to its longer run equilibrium, I think for various reasons, interest rate is a non-monetary factor based on the long run. It should come back, but it doesn't come back immediately. It slowly moves up. So now consider the exchange rate, which is the interesting part. So consider an investor who is investing at point T0. At that point of time, the interest rate on US dollar instruments, that interest rate is low. So you're going to invest in US dollar denominated instruments at that low rate only if the dollar is going to appreciate. Because if the dollar doesn't appreciate, then you're getting a lower return. Remember what we started with. Your return depends on the interest and the exchange rate movement. So the investment in US dollar denominated debt instruments would be there in equilibrium if, along with a low interest rate on dollars, there is also an appreciation of the dollar, so that the two together give you the interest rate R1, which is what you can get on the euro. So we are assuming that nothing happened in the euro bit, it is the US that you are considering. So when the interest rate is low, it must be that the dollar is appreciating, and that is the part which is being shown here. So this is price of euro coming down, which is another way of saying that the dollar is appreciating. So as the interest rate goes up a little, in the next round you don't require so much appreciation in the dollar, because you're getting slightly higher interest rate. And as the interest rate keeps going up, you need less and less appreciation, till you come to a point like this, where the interest rate on US dollar denominated instruments has become equal to R1, so that you don't need any compensation in the form of appreciation of the US dollar. So the rise of the interest rate must be accompanied by appreciation of the dollar. But there's another bit, which is that consider, let's come back to this diagram. What does this say? Due to money increase, the price level goes up, and we also know that if the price level goes up in the long-term context when you're comparing, then it must be that the exchange rate depreciates. So the US dollar must depreciate due to the money supply having increased. due to the prices having gone up in the US. I repeat this. The US has increased money. Therefore, the prices in the US go up. Therefore, its currency must come down. Currency coming down and prices going up are two sides of the same thing in this context. So, but we earlier argued that in that path to the equilibrium, if the interest rate is rising, the dollar must appreciate. So we are now saying two things. One is that the dollar must show depreciation insofar as the initial position and the final position is concerned, but that it also must show appreciation on the path from one equilibrium to the other. The two together are possible only if the dollar depreciates not from here to here, but instead from here to here. So you have an overshooting. So the initial equilibrium is this, the final equilibrium is this, but the interim equilibrium, if you like, is that we move from E1 to E2, there is a jump there, and then from that jump it comes back. So there is an overshooting involved here. This is interesting because we do want explanation as to why exchange rates are so volatile. Why do they fluctuate so much? And here you have one story which tells you why the exchange rate won't move smoothly. It would be more volatile than would be shown by just a simple jump from E1 to E3. It instead moves from E1 to E2 and then back down to E3. The previous diagram was for a change in the amount of money. This is a change in the growth rate of money supply. Okay, so this is the amount of money, and the growth rate would be when you're considering the change in money upon the money in one period. So let's look at the first one. On the x-axis we have time, on the y-axis we have the money supply. Y-axis shows the amount of money. The growth part is shown in the fact that this is an upward sloping curve. So you have two straight lines, initially with slope pi and thereafter with slope pi plus delta pi. Delta pi is positive. So the slope pi that measures the growth rate of money. And thereafter that slope has increased, which means that the growth rate of money has increased. So money is increasing at a constant rate from 0 to T naught. Thereafter again it is increasing at a constant rate, but the new constant rate of growth of money is higher than the old constant rate of growth of money. And at point T naught we have what we call a kink in the which reflects an increase in the growth rate of money. Just to put it in an example form, in India, let us say the money grows at 15% per annum. So, and let us say it continues to grow at 15% per annum for several years. And then let us say the RBI increases the growth rate from 15% to 18%. So you have a permanent shift from 15% growth rate of money to 18% growth rate of that would get shown in a diagram like this. The first one. Come to part B, that is the interest rate, and that is the nominal interest rate. So we have I'm getting a bit constrained with the limited space I have at the moment for this. So nominal and real interest rate. What is shown here is the nominal interest rate. The nominal interest rate to begin with is R1. It is constant. This is a very simple word in which the interest rate doesn't change from origin to point T0. And then at T0, since there's a change in the growth rate of money, and this in the long-term context translates into an equal rate of growth of prices. We're talking about long-run relationship between money and prices in a simplified hypothetical word. We earlier said that there is a bit of complication to that. So this is simple. So what this shows is that the interest rate goes up from R1 to R2. I is equal to R plus phi E, and here for simplicity we are taking a case where I is equal to R plus phi. I is the nominal rate of interest, R is the real rate of interest, this is the expected inflation, E for expectation, this is the actual inflation. We are taking a simple case here where there is no difference between the inflation that people expect and the inflation that is realized in the economy. The two are equal. And it is also the case here that this is equal to the rate of growth of money. So these three are the same. The rate at which money grows, the rate at which prices grow, and the rate at which prices are expected to grow. As I said, it's a more simplified word. So, in that, if you increase the growth rate of money, remember what happened in the first diagram? The growth rate of money goes up. Since the growth rate of money goes up, the inflation rate goes up in this simple way. And since this part of the nominal interest rate goes up, the nominal interest rate jumps at point T0. So before T0 it is at R1, after T0 it is at R2. This is to be accepted. If you like an example, you could consider an example of a country which shifts to a higher growth rate of money, or you could consider a cross section. Why is it that to take an example that I considered earlier, the interest rate in India is let us say 10%, the interest rate in US is 2%. Why is that? One simple straightforward explanation of that is that the rate of growth of money here is higher. The rate of growth of prices is higher. So you have a jump from 2% to 10%. Here, assuming for simplicity that R1 is associated with zero rate of growth. The 2% is zero rate of growth. But the point is that there is a jump in rate of growth of money, in rate of growth of prices. Any country with a higher inflation rate has a higher nominal interest rate as a style right. So that is part B of the diagram. Come to part C. Here is where there's a bit of complication which enters. But to talk about the simple part first. The simple part first is that from point origin to point T naught, the money supply is increasing at the rate phi, and so is the price level increasing at that rate. On the y-axis, we are showing the price level. The slope is phi, which is the rate of growth of prices, which is also the rate of growth of money. So the slope of this line is the same as the slope of that line. Okay. At point T naught, you have a jump in the growth rate of money shown up there, and after T naught, if you see part A of the diagram, the money supply is increasing at the rate phi plus delta phi. And that is also the slope of this line segment. So the prices are also increasing at the rate at which money is increasing. Now, to explain why the jump, here I am not making a distinction between expected inflation and actual inflation. Take the two to be the same. We are assuming here that the income is given. Though this is we are considering time in this model. What is happening over time, but we are abstracting from growth. So consider an economy which is not growing, the national income stays fixed. You could consider that as full employment or less than full employment. That is not the important part. The important part is that it is fixed. Looking at only the monetary factor here. So observe that the inflation rate has gone up because the money growth rate has gone up. If that happens, then also here let's consider the sign. What this sign means is that money increases with respect to income. The demand for money increases with respect to income. Demand for money decreases with respect to nominal interest rate. So, if the inflation rate goes up, because of which the nominal interest rate goes up, then the demand for money falls. As we showed earlier, holding money has an opportunity cost. So, if you are living in a country where the inflation rate is high, then you would tend to economize on money more. You would hold less money. It has a larger opportunity cost. So when the example I just gave was cross-section, considering two countries. In one country the inflation rate is higher, therefore the demand for money is lower. You can also consider similar examples where you have one country but two time periods. In one time period, inflation rate is low, and then the economy shifts to a higher inflation rate. When it shifts to a higher inflation rate, then the demand for money will come down. For the demand for money to come down, but remember the supply is given exogenously. So the central bank has pumped in a certain amount of money which is exogenously given, but people don't want to hold that much. So how is the adjustment going to be brought about if the central bank does one thing and the people want to do another? Well, you have a variable of adjustment which is the price level. So this is given. This is what the public decides. This is what the central bank decides, and the adjustment variable is P. So what is happening here is that there is a jump in the price level. What the public says is that our demand for real money balances is lower because you increase the inflation rate. So the supply of real money should also be low, but the supply of nominal money is given by the central bank. So the only way you can match the two, bring about an adjustment, is that the price level goes up. If the price level jumps, then the real money supply will come down and it will get equalized to the demand for real money balances, which is lower. So you have a jump in the price level to bring about that adjustment. Am I clear?
Why would people demand for money use?
Let me give you an exaggerated example, or maybe even a realistic example. Suppose you are staying in Latin America and the inflation rate is 500%. So from morning to evening, the real value of your money balance can come down. So you would really want to economize on money holding in such a way.
The people, the way actual people perceive is not the inflation rate based on the prices that go. People don't think in terms of inflation.
Alright, fine. People think in terms of prices. So let's think in terms of prices. So the prices go up. The prices go up from month to month, from week to week, from morning to evening. So since the prices are going to be high, would you like to hold a lot of money in your pocket, or at home, or in your safe, or in a current account which gives a zero account, zero interest?
I will convert it to goods as well.
You would convert it to something real.
Some commodity.
Some commodity.
But that is an extreme.
That is an extreme case.
They talk about in a general perception where the inflation is high but not that high.
Sure.
Where your general perception of will not be affected that much. 500%, 1000% inflation people will perceive based on price. Let me take the example of India over the past 3-4 years where inflation has been around 8, 9, 10%. As a perception, people cannot perceive those changes in prices. So how will their behavior change in that respect?
So, as I said, right at the outset, when I was answering the question, I said, let me consider an exaggerated example. So, it helps to convey the point. So, of course, it exaggerates. But now, coming to the quantitative part. So, we read on the qualitative part that higher inflation rate will reduce the demand for money. So, the quantitative part. The quantitative part now, how much do you respond? Now, it may be that when the inflation rate is changed and the money growth rate is changed, people don't realize the significance of that immediately. So in the short run, they may not respond, or they may respond inadequately, or not at all. I take that point, and in fact, there is evidence to show that. But in somewhat the long run context where you are moving from one growth rate to another growth rate, and let us say that you have given enough time for people to adjust. The